Oh, you're using the big fancy camera.
Oh, yeah.
All right. Let me know when you're ready to go.
Yeah, sure.
Action. You got the light good? I'll like it. So like it. Over my, show my beautiful feature. Mike with Intech Solutions. There are these guys down here. Here's our number in case any questions come up or any problems. The 888 number. This is the ABB ECH 550. This is also going to kill two birds with one stone here by showing you a drive plus the optional outdoor enclosure, which is a 3-hour enclosure. A few extra maintenance things because it's outside, especially here in the salt air, you know, up on the roof here. And we'll get to that part. You got a removable keypad right here. Okay, be very careful when you remove it. The best way to remove it and put it back. Best way to put it back in while we're doing that is kind of get a good feel for it in there before you force it in there. Sometimes we'll pop that board back and it'll go right in. You can take this out anytime, even while it's running. It's not going to shut anything down. You can also take this keypad and bring it to another drive if you're trying to do any troubleshooting, you know, by swapping keypad. It won't bring change the program. It won't make any different changes. The program resides inside the VFD itself. A couple things we look at the display right here, top left-hand corner. We can see whether it's in auto, off, or hand. No problem. So right now it should be an auto. There it is.
Yeah, it says auto.
Yeah, exactly. The next one over here, you get that arrow going around circles. When it's running, it'll spin. So will the motor. But for a remote op, where the motor's far away, that may be helpful to you. So you can see that it is running. And on the top right-hand corner here, we have what speed the drive is being told to go. We look down here, the three big lines. These are all changeable, but we set them up for you for things that you're most likely be interested in. The top line is going to be the frequency the motor's running at. The next line is going to be the amperage. And the bottom line is the milliamp signal from the BMS system, which is also your speed control. How many milliamps, between the 4 to 20 milliamp signal that it's being told to run. In this case, it's right at 12 milliamps. Well, that's why it's going. It's about 30 hertz. The keypad up here, we've got two soft keys, they call them. Not because they feel soft, which they do. You can check them out, really nice and soft. But they call them soft keys because they change their function by what it says right above them. Right now, this one will say nothing. Okay, and it won't do anything. This one says menu. If we hit menu, we now have enter and exit. Enter and exit. Exit out right now. So when you're going into editing parameters and like that, that's where you hit edit, save, exit, any of those types of things. Just look right above. It'll give you your choices. Also, if the drive were to go into a fault, you'd have a red light up here, and it will say fault right there. It'll say fault, what the fault is, both the number and also exactly in plain English or 12 other languages if you choose to. But right above here will say reset, and that's how you reset the fault right there. And we can demonstrate that one. You have your hand off and auto buttons. Okay, auto, your BMS is in control of the drive. Off, it'll stop the drive. Is this one all right to stop and play with? Okay, cool. So, boom, stopped, right? You put it back in auto, and it restarts. You don't have to wait. You can also go between auto and hand and auto without going through the off position. You can't do anything wrong. So what it'll do is just start us out in hand right where we are in auto if we are running. If we're not running, of course, it'll start the drive. So if we know as we go into hand, you'll see this top right-hand corner, the speed the drive is being told to go is going to be highlighted now. As soon as we go to hand, it's highlighted right at the speed we were at. You can increase, decrease the speed. And we can go all the way up some. And we can hit auto. And it'll go right back to where it was being told to go from the BMS system. Last thing we have on the keypad here is the question mark key. I like to call it. Oh, the mystery key.
Yeah, that was rich.
Yeah. So the mystery key. This is actually a help key. Wherever you are in the menu, you hit that. It'll give you the information that would be in the manual. So, for example, if we hit that now, in our regular one, it says output display shows drive status and actual signals. Select signals in parameter group 34. Okay. So let's say we go further in. Let's go to menu, and we see parameters. We know what that is, but let's just hit it anyway. We hit that, and it'll say use the parameter menu to view and edit parameter values. Okay. Well, let's go into more into the parameters. So we hit enter, and we can go to, let's say, XL decel. Okay. I use this one because we all know what XL decel is, but just for demonstration purposes. Okay, what is that? We hit the help key, and it says this group defines ramps that control the rate of acceleration and deceleration. Great. Now we go into that group further to where we actually go to the parameters. And let's say we go to acceleration time number 1. What does that mean? Right now it says 30 seconds. We can edit it if we wanted to. Okay, up or down. Save. You know, okay, what does that mean? It says sets the acceleration time from 0 to maximum frequency for ramp pair 1. So lots of information right here with the help key. We'll go back again. We'll go all the way back to the main menu or the main display. We'll hit menu. Some things that are really nice to look at is change parameters. Okay, we have change parameters. It'll show all the parameters that we change. I particularly changed in this case. Somebody came behind me. All the things that I changed from the default. So things to set it up for your XL, your decel, your motor data, your control inputs, those types of things. And we can look at any of those, like maximum current, 9.7 amps. To change that to default was probably much higher. Change it to the FLA of the motor, things like that. Minimum frequency, 15 hertz. Another nice one is fault logger. It'll tell us our last faults and with the day and time. So the last fault was a DC undervoltage on June 3rd, 2016 at 9:05. Undervoltage is not unlikely to see in the menu. That's any time it's running, power goes off. If we were to kick this out right now, it would go into an undervoltage fault. So anyway, why not see? Let's go ahead and do that. Trying to keep itself alive. Okay. You can see the red light. It says fault. This is a fault that automatically resets. There she goes. She goes right back up again. It'll also reset too if it goes all the way, dies all the way off. So now you saw what a fault looks like. If we were to look at right now in the fault logger, it'll say again DC bus undervoltage or DC undervoltage fault 6:30 2016 at 8:16. And we can go hit details. We can see what it was doing at the time it faulted. We can see the time, status, most important frequency was at 30.1 hertz. Speed was at 904. Torque was minus 0.6. Current was 2 amps. The DC bus voltage was 424 as it was dying off. And that's it. We can hit diagnostics right here. So now the soft key right above this is diagnostics. Or we can look at the book. Or I should say the manual. The book, it'll give you a book anymore. Oh, it's online. Welcome to our new world. So it says check for missing phase in the input power supply, blown fuse, under voltage on the main. Well, killing the power is got an under voltage on the main, right? So that's real helpful. Take a look inside here, and do this while it's on. We'll leave it running now. Inside. Oh, I did bring a little.
Did you go over which exhaust fan this is exhausting?
That one.
Okay.
Yeah.
What actually is it in the building?
No.
Oh, okay.
I make the motor around circle.
This should be an isolation fan for one of the areas, or
EF6, serving the 6th floor.
Sixth floor?
Oh, that's right. That's what you said yesterday.
Here's the inside. So this is the drive itself right here. Okay. So our power comes in, or disconnect. We've got fuses there. If you come up to the drive and all 3 fuses are blown, don't just replace the fuse. There's something currently shorted. There's something bad. Like I tell people, 2 serious events may happen. You replace the fuse, nothing happens. It's not going to come back up again because whatever shortage is blown open is now the fuse, right? The other thing is the big pop sound is going to happen that you missed earlier. And it's always nice to miss those. There's something usually seriously wrong.
What if just one line's blown though?
One, then the drive will still run. So the drive will still operate at full load. It can go out and supply phase fault. But because the drive takes in, first thing the drive does is take AC and change it to DC. It really doesn't care if it's getting it from single phase or from three phase. In fact, we use it sometimes just for that, just to create three phase. So a fuse could be out its whole life. If you never really ran all the way up to 60 hertz and high low, you may never know it. Years. So yeah, if you see one, chances are it's good. There's a chance that one of the diodes on the rectifier shorted, that took it out. But all you do is clear that fuse. It's not too bad. But 2 or 3, you got something serious going on. I've been doing this for 22 years. I think twice I've had a case where we checked everything out, couldn't find anything, so what the hell, we put new fuses, and it came up and worked. And we never did know, something went across it somewhere and cleared, blew itself up. But that's 2 out of, thousands of drives. So generally, I can even tell you over the phone, just, no, we need to replace the drive, or, no, you got some serious wrong. Couple things here, just so you know what all the components are. That's your 110 control transformer. That transformer, all it's doing is taking the 110 for this heater circuit right here. There's a heater you see sandwiched in between here that runs off of this board. So if it gets cold out here, especially if it's not running, it'll bring the heater on to keep condensation from building up inside the cabin. Then we have the drive itself. This is the connection between here and the keypad. Once in a while, like I said, sometimes this board pops back. So if you take the keypad out and you put it back in and it doesn't come up, take a look to see if this board didn't snap out. That'll happen sometimes on this particular type. And we just gotta make sure these are actually snapped in there. Not a big deal.
What's the purpose of that panel coming off? Like,
you can mount
is it a remote or something?
There's a couple things. You can mount them, well, like this one's mounted not on the drive. Like you can see some of the drives inside here, where it's just a drive on the wall.
Yeah.
It'll actually mount, there'll be a cover on this so that it mounts right on the drive. Then you can take it and mount it other places. You can also take a copy of the program, upload it into that keypad and bring it to another drive. You have, let's say you have 10 drives on a wall, they're all similar. Like somewhere inside here, you got like 3, I'd say right next to each other. And you change one out, you can take one, upload it from that one, download it into the drive. It's like a memory stick. So you can use the keypad to transfer memory, but just moving the keypad around doesn't transfer the memory. You have to go into the program, go parameter backup, and load this program.
So parameter backup is how you would transfer a program?
A program, exactly. Parameter backup, you upload it into the panel, take it to another drive, and download that set in there. Also, when I do a startup, it's not a bad idea. A lot of guys will take these off and mark which one it goes to. Because all these I started up, the last thing I do is I upload a copy of the program into the keypad. A couple reasons. One, if we ever have to change the drive, we don't have to think about it. Put the drive in, drop it in. The other thing is, if somebody comes in, and this happens a lot, comes in after the control guys, they start playing, they have a little bit of knowledge, they start playing with the drive, now nothing works. Over the phone, I can tell them, just go download full set, and they'll say, well, what was wrong? I don't know. I don't care. Right? And they had to fix it. They put it back the way I left it. So there's kind of a copy up there. It's also real nice, too, if you want to do any testing yourself or playing with it, making changes. Hey, I want to do this, I want to do that. And then you go, oh, geez, I want to get, this is not working the way I want it. I want to get back. You can just download that program.
Like a default setting,
exactly,
right?
Yeah. I call it parachute. So you can play with it without worrying about getting it back to where you were. It's kind of nice. A couple of maintenance items on these outdoor units. You don't have to worry as much on the indoor. But the first thing covers all of them, and that's make sure everything's tight. It's a good idea once there's a run for a few months is to go in there and check to make sure everything's tight. For the factory wiring like these right here, you usually don't have to worry. It's not a bad idea. It's not going to hurt it. But ABB's got a really good torque spec where everything's really, really good on there, and they've already also been burned in. But as far as the field connections, is always a good idea. Once they've got to expand and contract a few times to do that, and then check that once a year. Give a good visual inspection. Make sure nothing's looking overly dirty, especially on these outdoor units, and make sure that you don't see any heating involved, going on, like in the wiring and those types of things. The next thing on these units, or not on all units, is you want to be able to once a year clean out the heat sink. In this case, you got to take this plate off right here and go up there with some air. you know, the canned air stuff doesn't have enough power, you know, and it's also stupid expensive. I use a little shop vac, reversible, blow up in there, get that stuff out of there. On these units, because they're outside, it's even more important. I would recommend putting a filter, dropping this down, putting filter material across here, especially being in the city because you got a lot of salt going in. And that cooling fan sucks up from up here. The cooling fan is actually behind here on top. And what it does, it blows air up across the heat sink. And that air, if it's salty, as it can be here, is going to get to the fan and that kind of stuff after a while. So I'd recommend they don't. I wish they would come with them. Not my decision, but yeah, any kind of filter material. What you just take these screws out here, drop that plate down, put a piece of filter material in there, boom, you're good to go. It's not going to void the warranty or anything. And especially, even though it will restrict the airflow somewhat, you got a couple of things in your favor. You're in the city, it never gets hot. These things are designed to be on rooftops in Fresno, so you've got plenty of extra cooling ability. Also, these are probably not going to work with their full load, of course, also. So here's your control wiring here. This here, you can see a silk screen on here, analog input and analog ground. That's your speed signal, okay? So I always like to use car analogies. That's your throttle right there. And then this one and this one right here, that is your start command, okay? 24 volts, digital input 1. And the control guys are putting in a relay over here with a light and everything. So they're bringing 24 volts a year, closing it, and then closing our contacts here. That's your ignition switch. And then finally, you got a run status here. This goes back to the BMS system, tells it when, so they're telling it, yeah, I'm telling you to run, are you actually running? So it sees those things together. The pretty simple control logic, start, stop, speed. When it comes to troubleshooting on drives, again, I always like to use the car analogy. You need two things. You need to give it a speed and you need to give it a start. Right? You give just one or the other, you're not going to get to where you need to go. So a lot of times I'm talking to people over the phone. They're saying, but I'm giving it 10 volts or 20 milliamps, it's not running. I said, well, go in your car right now in the parking lot, push your foot to the floor. What's the car do? Nothing. What do you got to do? You got to start it. So you can give it a speed signal, but if you don't give it a start. So if you walk up to this drive, and in this case it's nice to have this relay here, you don't see that relay on, it's just not telling it to start. Next step to do is put it in hand. If you run it in hand, that means the drive's okay. So if you put it in hand up here on the keypad and run it up and down, the drive itself is fine. What happens is a lot of people get tunnel vision around a drive because it's a fancy piece of equipment, and they lose their normal troubleshooting things, you know, and they get focused on the drive. Meanwhile, the drive is sitting there. If it doesn't have a fault on it and it's just sitting there, chances are it's just the control system is, for whatever reason, it's not telling it to run. But they always kind of, focus on the drive. Same thing, let's say you get a fault, earth fault, overcurrent fault, short circuit fault, all those faults. Any fault's not a bad idea to do this, is kill power, remove your motor wires, okay? Cap them off, save them off. Turn the drive on, again, run the drive up. If the drive runs, your chances are the drive's fine, you've got a motor problem. Because just because the fault comes up on the drive doesn't mean the drive's saying, I got a problem, it's saying my motor's got a problem. So you try to do that process elimination. Other good troubleshooting too, let's say, well, I removed it, it's coming up with an earth fault, as soon as I try to start or an overcurrent, I remove it and I don't have that. The next good troubleshooting too, and a little harder here, because it's sitting out here, but like the ones over here in the pumps, where we've got 3 of them next to each other, you can wire that drive to the other motor. If it runs that motor, you've got your good drive. It's just a simple process of elimination you would normally do in mechanical stuff, but because of the drive, people miss it just because they get overwhelmed because it's a high-tech piece of equipment. So you can take one of the drives and just get some wires, bring it over to the other motor, and run that motor. If it runs that motor, fine. Okay, we do have a bad motor. But nobody wants to change a motor if it's if there's no problem with it. Then you really look foolish and you waste a bunch of time. But you also don't want to change the drive. I see that a lot, where drives get replaced, and there's nothing wrong with the drive. The whole time it's been the motor, And these aren't cheap. Right. Little ones aren't so bad. As you get up to the bigger ones, it gets really expensive. So yeah. Oh boy. This little program. Hey Zach, does the sewer come out over here or what? Yeah. So, any questions pop up anytime.
When you say that you can check the drive by disconnecting the motor,
Right.
What will the drive indicate? Because without the motor,
Well, it'll give you frequency with no amperage, of course, because there's no
Right.
motor attached. But
Okay.
it'll run up with no problem.
Okay.
And a lot of times I tell people over the phone, you know, do this. Go, geez, I never even thought you could do that.
Yeah.
You know, but yeah, it won't
So
blow
you won't-
up. It won't let the smoke out. Yeah.
Okay. But so it will run. It'll give you the frequency. It'll tell you it's giving a frequency, sending a signal.
That's correct. Right.
Okay.
But of course the motor won't turn,
Right,
and
you
you
won't
won't have
get-
any amperage.
Right,
Right.
okay.
Yeah. And sometimes you get that call too. So the drive says it's doing 60 hertz. Something wrong with it. It's 0 amp. And I realize they have the disconnect open through the drive. Just local disconnect, things like that. You gotta hook up that motor. It doesn't know otherwise. It's not magic.
Got it.
So, yeah, not a whole lot of maintenance to it. You know, these ones, you know, like I say, especially you want to make sure that that's clean. Filter is going to get you a long way, to have to worry about that cooling fan. You want to take a look at do you want to take a look at the other one? Oh, we want to take, yeah. That's right.
Something else to mention is a lot of the equipment in your facility have like fans and pumps. Fans more than pumps have local disconnect at the equipment. If for whatever reason those local disconnects get turned off and you're seeing your drive ramping up and nothing's happening, make sure that the drive has settled out. It's not running at 60 hertz when you go and throw
Well,
that
you
night
want to
switch.
stop it, yeah.
You want to stop the drive before
stop the drive.
you turn that local disconnect back on.
Correct.
Otherwise,
yeah, the drive, the motor, a stop motor looks like a dead short. If you know, measure ohms drops, it basically is a dead short, pretty close to it. And it all of a sudden tries to line start, tries to send everything through that motor. The drives will trip out. They're both not, you know, compared to drives from earlier days would blow on the first time. As soon as you did that, boom. But these have inductors on the output, so they will survive it. They'll trip and over current. Still not a good idea to do it a lot. If you keep doing it, I'm sure it's going to break down the output transistors.
Now, so are these drives on separate power supplies from the motors, or you got a disconnect at the panel, and then you got a local disconnect at the motor? Is the drive on the panel disconnect, or is it a separate power supply?
Generally, though, if it's in, like this one doesn't have it. Yeah, because you're so close. But there's cases where was there disconnect over there?
yeah, there's a local disconnect.
Oh, there's one. Oh, okay. Oh, yeah. Yeah. So it'll come from the breaker, from the breaker panel to here, then here to the disconnect to the motor.
Okay. So basically, the drives are on the same circuit as the motor.
Yes.
Yeah.
Yeah.
Okay.
Right. It goes right. It goes through. Yeah.
Every drive has a dedicated circuit from the main panel, and then from the drive to the PC.
Okay.
Right. So killing that you'll still have power here. So opening that disconnect, the power.
We'll still have power here, but if we kill the breaker,
then you're dead here.
then we're dead here. So if we hit the breaker, we don't have to worry about anything because the drive's going to turn on.
It's
Power
gonna
up
turn
stops.
off. Right, exactly. It's gonna see no power. It's gonna go into an under voltage fault.
Right.
And then go completely off. When you bring it back on, it'll just come right back on.
And it'll do its normal
Yeah, you don't
startup.
have to. I mean, as a course of habit, that I've been doing this so long, I usually do stop the drive before I'm going to kill it here or up there. I usually stop it. One reason.
How do you stop it? How do you stop
You
it?
hit the red
The
button.
red button.
Okay, that's it, right?
Yeah,
Yeah.
exactly.
You don't have to like ramp it down or anything,
Nope,
just
no.
off.
No, just
Okay.
like right, boom, off, yeah,
Okay.
and then go boom back on. Even if it's already turning, it'll catch it and just take off. As just a matter of habit, I usually stop it before I kill it, but it just because it won't record an under voltage fault.
Right.
A lot of times, guys are doing troubleshooting, and they've got a problem. They don't know what the problem is, and they look and it's got under voltage faults in it. You know, it's voltage going away. Well, yeah. At some point in its life, power's going to go out, right? It'll
Right.
be generator testing or a storm or someone just turns the power off. Under voltage faults in memory, don't even worry about it. Yeah. So they start chasing up the wrong tree. And I mean, you know, I get called out on, I would say about half of our service calls is nothing wrong with the drive. just because it's a drive and people get freaked out. It's probably getting a little better now. People get a little more familiar with the basic troubleshooting. So a lot of times I'll go out there and they'll say, oh, the drive falls and shut down. And I get out there. What's nice about the 550s that previous versions and other manufacturers don't have is that date and time on there. Because it would just record a fault, but you don't know if that was from 5 or 6 years ago. So I've come out to jobs and go out there and go, okay, your last fault was an earth fault. Okay, it was a ground fault basically. It means a ground fault in the motor. But that was 5 years ago. They go, oh yeah, that's when we changed the motor. Yeah, the motor went bad. And meanwhile, it was the BMS system shutting it down for whatever reason, or a safety circuit, you know, an overpressure, anything like that. Yeah. You know, shut it down. So when if you see the drive, like I say, if you don't see a fault on there, don't worry about it. If you see an alarm, so there's two different things. There's fault, there'll be a red light. An alarm is green and flashing. Don't freak out on the word alarm. I wish they wouldn't use the word alarm.
Yeah, it's kind of like backwards, right?
Well, not really. A fault is the difference between a fault and alarm. Alarm will not shut down the drive. It's not a serious problem. But it should just be called notification. Some alarms are good. Let's say the main cooling fan goes out. When it gets up to 95% of its trip point before it goes to a fault, it'll give you an alarm. Okay, that makes sense, right? Then it goes to a fault and actually shuts down and gets hot. But there's certain ones. Let's say, for example, in some cases we don't want to use the hand button. We use these things, these big, you know, this size, you know, this model, but you know, 300 horsepower on a chiller. We don't want somebody to put that chiller in the hand and run that chiller motor without the oil and all the interlocks that the chiller has, right? So you turn the ability to put it in hand off. Right? If you hit hand, it'll say alarm, button disabled. Well, that's not an alarm. People freak out like that. And right. They see it says alarm very big and the number, and right down below it in smaller print, it says what it is, but they see that flash alarm, they go running for the hills. You know, there's also, if your fire control goes, if anyone's that you have fire shutdown and it opens up the contacts, it'll say alarm 2021. Like this flash at you. Well, it says start enable 1 missing. That's the enable circuit to say, my enable is gone. My ability to run is gone because I'm being told to shut down. Is that really an alarm? No, it's just a notification. Hey, just want to let you know the reason I'm not running is because I'm told I have a safety open. I'm not supposed to run at all. So don't freak when you see alarms. That happens quite a bit. Well, fault. Okay, that's a condition. And again, can't reiterate enough that if you see a fault, doesn't mean the problem is in the drive. The drive may have shut itself down to protect the motor, protect itself, and so on.
And one question.
Yes.
If we do the fire drill, it's going to be in fact to this?
Not this particular one, but some of them will shut down, right? Some of the ones on the floor.
These ones are wired, they're interlocked with fire alarm. All the exhaust fans are interlocked.
So when
that red wire in there is.
Okay, so I think I know where you're going with the question, but when it goes into alarm and it shuts the VFD down, will it automatically restart?
Yes, yeah.
When the alarm is reset?
As long as the fire control panel can close those contacts again, which they usually will, it'll just reset. As long as the BMS system is telling it to start also. Okay. Because it could be, sometimes it happens, the fire shuts it down, the logic in the BMS system, some of these guys, I don't like the way they do it, they go, oh, I'm telling you to start, and you're not starting, so don't start. You know, they'll take away the start command. Okay. Well, if it's not starting, who cares if you have the start command or not, right? Yeah. So then sometimes at the BMS system, you got to clear it. You know?
We got 2 air handlers in our current building that we have to manually restart them after an alarm.
Yeah. So the way these ones are wired, fire alarm is interrupting at 24 volts going to the interlocks on the drive. So BMS is still sending their signal. We're just taking that voltage away for fire alarm, and then we put it back when things clear, and it picks it back up where it left off.
Okay, great.
So when you're in a fire mode, BMS thinks everything's just fine and dandy. We just switch the voltage.
Okay.